Finally, we are on the last problem. It is 2D for the supplemental reading, the nth derivative test for relative extrema. We're going to find the stationary values or the critical values. Problem 2D, exercise 9.6 of the following function. Y equals 5 minus 2x raised to the 4th power plus 8. Let's take the first derivative. It's going to be 4 times 5 minus 2x times the derivative of the inside function, negative 2. That gets us negative 8 times, raised to the power of 3, sorry. Negative 8 times 5 minus 2x raised to the power of 3. This gets us 0 when 5 minus 2x is equal to 0, which is when x equals 5 halves. So that's a critical value. Let's go to the second derivative. It's going to be negative 24 times 5 minus 2x times negative 2, which equals 48 times 5 minus 2x. So using the nth derivative test, if we just plug in the value of 5 halves, we're going to get 0 again. This is raised to the power of 2, by the way. Again, if we take the if we try to use the second derivative test, we're going to fail because this equals 0 when we plug in 5 halves. So that's not going to work. So we must use the nth derivative test. I know you're shocked about this. I am in complete shock about it. So let's get the third derivative. That's going to equal, what is that, 96 times 5 minus 2x times negative 2, which equals 180 plus 12 is 192. Negative 192 times 5 minus 2x. Again, if we plug in 5 halves, we're going to get 0, so that's not going to work. So let's go to the fourth derivative, which is just going to be 192, negative 192. The fourth derivative is even, so what we can say, because this value is less than 0, negative, the function is going to be concave down. And at the value of 5 halves, we're going to get a relative maximum. And we are done with this problem, and we are done with this section, and that is the nth derivative test. Hopefully you see how useful it is in, tight spots. I certainly do. Let's move on.